Hello friends, this video on p-block elements part 12 is brought to you by examfear.com. No more fear from exam. There are various compounds of boron. One is the borax, there is orthoboric acid, third is diboric, and the fourth is boron trihalide. So we'll discuss all these compounds now of the boron. The first is the borax. The borax looks something like this. It is a very important compound of boron and its formula is Na2B4O710S2O. Or if you want, you can write this fashion also. Both are same actually. Na2B4O5OH4 8H2. If you see the structure of boron, if you see, this is actually a cation with positive 2 charge. If you see there, sorry, negative 2 charge, anion. This is minus 2 charge, right? This is minus 2 charge. And then here you add sodium, 2 ions of sodium. And then we have 8 water molecules. And then here you have 8 water molecules. 8 water molecules. Like that. This is the structure of borax. If you see the way it is linked is, there are 4 borons, 1, 2, 3, 4 borons, and all these are linked with oxygen in this fashion. And there is oxygen here also, right? And all these borons now are linked with OH molecules, right? And now if you see, these guys have 2 negative charge, correct? So these borons, if you see, these are sp2 hybridized and these are sp3 hybridized. 1, 2, 3, 4 bond sp3 hybridized, 1, 2, 3 bond sp2 hybridized, and these 2 borons has which are sp3 hybridized has negative charge. So overall it has -2 negative charge. It's a anion and this is sodium cation Na plus, and it has, if you see now, this has extra 8 molecules of water. So total, if you add, if you see, right, how many hydrogen molecules? 1, 2, 3, 4 hydrogen molecules, and that means 2 water molecules, right? Because 2 water molecules will have 4 hydrogen molecules, 2 to 4. So total it has 10 water molecules. But if you want, write a concrete structure, actual structure, this is like this, because 2 sodium ion I have, then I have this, this is +2, this is -2, this is ionic, actually this is cation, and this whole thing is anion with the -2 charge, and then I have 8 molecular water. But it is a little complex to write in this fashion, so we write Na2B4O7.10S2. But this is the actual formula for the borax, and this is the shape. If you see, there's 3-dimensional. If you see, these are my borons, the pink ones are my borons, and let me write, these are my oxygens, the red ones are my oxygens, and the white ones are my hydrogens. This is the structure of 3-dimensional structure of borax. So as we have told, the boron undergoes sp2 and sp3 hybridization. As I told, these are sp3 hybridized and these are, the other ones are sp2 hybridized, right? 2 sp2 and 2 sp3 hybridized. Let's understand something more on borax. So the first thing you can see, this is a crystalline, white crystalline solid, as you can see here itself. The second property is it is dissolved in water. So it doesn't dissolve in cold water, but in hot water it dissolves. In cold water it doesn't dissolve, but in hot water it dissolves to form alkaline solution. This is the reaction we have. This is my borax. It reacts with water, cold water, hot water, to gives sodium hydroxide and boric acid. And if you see, this is a strong base. And I told this boric acid is a weak acid. So it's a strong weak acid and strong base. So it's a basic solution or alkaline solution. Correct? On heating this borax, it loses water molecules first and then swells up. And on further heating, it turns into a transparent liquid. And when this liquid solidifies with some other metals, it gives a color to the glass. It comes as a glass shape actually. When it solidifies, it becomes a glass shape. And when this glass, actually when you heat this glass with some metals, it gives different colors. Correct? And this is used to determine metals actually. For example, manganese will give you brown color, right here. Or right here somewhere. This is brown. This manganese will give you brown color, right? Chromium will give you a green color, right? Copper will also give you a green color. Nickel will give you a brown color. Cobalt will give you a blue color. So we will talk about these. So different metals they give different colors in the bead test. What we do in the bead test, we take this platinum wire because it's unreactive, right? And then we take some borax and when you heat this, this water molecule goes off, right? And it becomes Na2B4O7, right? When you further heat this, it solidifies into a glass-like shape, this one. And this guy, when it reacts with the various metals, this guy, B2O3, this guy, when it reacts in the, it gives different colors in the oxidizing and reducing flame. So this guy, if you see, this part is the oxidizing flame, if you see, and this lower part is the reducing flame. So this color I wrote for the oxidizing flame actually. So what happens is we have got this B2O3 and this is my transparent bead. Actually the whole thing is called transparent bead, but I'll concern more about this part now. This is my transparent bead now, right? Now when I mix this with some element and when I heat this, it gives different color. We'll see some examples. Let me finish this part now. So if you see, right, these transition metals, most of the transition metals actually, not all the metals, but the transition metals, they have special colors. For example, I told cobalt gives blue, chromium and copper give green, and this is, magnesium and nickel gives brown in the oxidizing flames. These are the oxidizing flames. It gives these colors, right? And these are used to identify them in the lab, and this test is called Borax bead test. This is the platinum wire, and this you first add this borax, you heat this, water is gone, and again you further heat, you get this bead. This is called bead actually, and then with this bead you add some metals which you want to test. You want to identify the metals, and then again heat in the oxidizing flame. You get different colors, and with that you can find. For example, one example is given is when this borax bead which we have got, you add some cobalt in this loop, right? And then when you heat this in the oxidizing flame, you will get what? Cobalt gives what? Blue color. So the reaction will be like this. For cobalt, I have this one, but I have this bead. When you heat this, you get COBO2. Right? This is cobalt metaborate, and this is blue in color. These I am talking about in oxidizing flame. For example, nickel, if you see NiO, you add this B2O3, you get NiBO2O2. That is nickel metaborate, and this is brown in color. And this is blue in color. Similarly, for manganese, I'll write the reaction here. For manganese, if you heat the same thing with bead, that is B2O3, you get MnBO2 not able to write clearly, but this is MnBO2 and this is manganese metaborate. This is brown in color. Correct. Similarly, chromium will give chromium metaborate CrBO2O3, and copper will give copper metaborate, and these guys have different color, and these will give the oxidizing flame. Correct. Similarly, in the reducing flame, it will give a different color. For example, copper in the reducing flame, they will give a bottle green color. Correct. So with this, the logic here is not to tell you the colors and all. You should not understand the color or remember the color. The logic here is that the borax gives different colors for different transition metals in the bead test, right? And this differs in the oxidizing and reducing flame. So if you see, this part is the oxidizing flame and this part is the reducing flame for flame. So if you heat somewhere here, this is the reducing flame. This is, if you heat somewhere here, it's the oxidizing flame. So with this, we are able to identify different metals. This is the use of borax here, because the borax gives a borax bead, and these beads give different colors to different transition metals, and this helps you identify different metals. Please note, the platinum wire is used here because this is little unreactive. So let's talk about the uses of borax. The first is for the soldering of metals. It is used. You must have seen the electronic circuits. They are soldered, and they are soldered using borax. For the glass, Paris glass, because the heat resistance, borax is used. For the borax bead test we just discussed, it is used. It is also used widely in candle industry. It is used in the laundry. In laundry, it is used borax. It is also used to create earthen pots. These are some of the use of borax. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.